Hey everybody, thanks for checking into another math video. This one is going to be about determining the number of solutions to a quadratic equation. You might be thinking, wait a minute, I thought there were always two solutions to a quadratic equation. Isn't that what we've been saying this whole time? That there is always two solutions to a quadratic equation? Did something change? No, nothing changed. All right, it's just a little bit more complicated than that. Okay, so let me explain. The It is true that there are always two solutions to a quadratic equation. Okay, that is not in doubt here. However, sometimes those solutions come in different types. There are different types of solutions, in fact, to a quadratic equation. Okay, so that's not helping. You know what? Here, let me restart this. Okay, let me just kind of back up a second, and we're going to do it this way. Okay, everybody. Hey, thanks for checking out another math video. This one is going to be about determining the types of solutions to a quadratic equation. All right, let's try it that way. Okay, well, let me explain here. The solution to a quadratic equation actually come in three different types, but we've only seen one type. So that's why we haven't really talked about this yet, because all the times we have solved a quadratic equation so far in our class, it's only been this first type. This first type is what we're going to call real and unique. Okay, the numbers are real numbers, which I'll explain later about what that means, and they are unique. That is, they're different from each other. Two different real numbers. That's what we've gotten almost every time. Once in a while, however, you could solve a quadratic equation and get two numbers that are the same. So they're real numbers and they are identical. So two real numbers that are the same number. I know that sounds kind of funny, but the third type is that they are not even real numbers at all. All right? So that's what this video is about. These three different types of numbers, and I know you might have some trouble with some of the stuff in this video. Okay, it's kind of confusing and kind of strange, but let's try to do our best here to dig in here and see what these are. So the first kind, the ones that we've seen already, are things like this, where you've got a parabola that crosses the x-axis in two different places, or if you solve a quadratic equation and you get two different numbers. All right, these solutions are all real and unique. Okay, you get two different numbers. It's a pair of two different numbers. All right, so that's why we call them real and unique. They are different from each other. That's what we've seen most of the time. However, you can imagine that a parabola might not actually cross the x-axis in two different places, but just touches it in one place. That place right there, where if the vertex of the parabola was right on the x-axis, there would only be one place where it touches it, all right? Not two, but just one. And in the algebra that you might run into for something like this, you might have a part of the equation where you end up solving something like this. X minus 4 squared equals 0. Okay, so you're going to solve that by taking the square root of both sides, and you get x minus 4 equals 0. Well, normally when we do this, taking the square root of both sides, we add that little plus minus thing in front of the square root, right? But plus minus 0 doesn't really make any sense. There's no such thing as positive or negative 0. 0 is actually the only neutral number. It has no positive or negative quality to it. So when you solve that equation, you just get x equals 4. Yeah, you're done. But this solution here is kind of interesting in that we still say there are two solutions, but they are identical. So we got x equals 4 and x equals 4. I know that sounds like we're saying, kind of, playing games here with the words, but now the third type is something like this. What if the parabola that you're trying to find the x-intercepts of doesn't even have any x-intercepts? It doesn't cross the x-axis, so there are no x-intercepts. What if you tried algebraically to find those solutions? Well, if you did, you might end up with an equation looking something like this, perhaps. X plus 2 squared equals negative 1. And this might happen after you've already done a couple of steps of the algebra. Okay, so let's say you get to this point here, and you're going to solve it by taking the square root of both sides. All right, well, that gives you just plain old x plus 2 on the left side. Cool. But on the right side, you got square root of negative 1. What is the square root of negative 1? Wait a minute. How can you have a number that when you square it, it equals negative 1? That doesn't make any sense, right? Anytime you square a number, if you square a positive number or if you square a negative number, squaring a number always makes it positive. So how can you have the square root of a number that's negative? All right. Well, this is a different kind of number. All right. We call the solutions to equations like this not real numbers. And this is a whole other conversation that we need to have. And so this video here is just kind of an introduction to the mere existence of these kinds of numbers. All right. And this is why this topic, solving quadratic equations, is such a huge, huge topic for you as a math student. Not only are you finding the solutions to equations that have two solutions, that's by itself kind of different. All right, you haven't solved equations before up till now where you got more than one answer. Okay. Also, you're learning about this new kind of graph called a parabola, and its vertex, and its line of symmetry, and its x-intercepts, and all of this different qualities about this new graph. That's a big deal all by itself too. And now what you're going to see is that there is actually a different kind of number. All right. That's totally mind-blowing. All right, and that's why this topic is such an enormously important topic for you as a math student, because it introduces you to getting multiple solutions to equation, a different kind of graph, and actually a totally different kind of number. All right, that's pretty amazing. And so that's going to be a conversation that we will have in great detail, and I beg you, please keep practicing, keep asking questions. All right, I know this is not going to make sense right away. All right, so ask questions. Ask me that question that you say, what just doesn't make sense. Just keep asking those questions, please. That they're super important for you to struggle with this idea and come to grips with it. Okay. Anyway, let me just summarize a little bit of the main points of this video here before we sign off. Quadratic equations always have two solutions. Okay, that is something you can count on forever. All right, it's always going to be true. However, those solutions can be of three different types, and the first type is two different or unique real numbers. That's the kind we've seen most often. But we could also get two identical real numbers. All right, and I know that sounds like I'm playing games with the language here, but please bear with me. There can be two solutions that are the same. That is allowable. All right. Finally, you could have two non-real numbers, which also is very strange. And that's what happens when you try to take the square root of a negative number in your algebra, or if you're dealing with the graph of a parabola that does not cross the x-axis. Okay, so this is brand new stuff. All right, I know this is this is a big deal here. I hope you stayed with the video here to the very end. All right, so keep asking questions, keep practicing, be cool, be strong, be well, and once again, thanks very much for watching. I'll see you soon, I hope. Bye-bye.